this section we'll be talking about logic. Logic was first systematically studied by Aristotle. Also Leibniz, who was the co-developer of calculus, started introducing symbols to represent statements. Now this idea of using logic and sets and symbols to represent statements actually boils down to what the basics for computer programming nowadays. So this could be very useful for those of you who are going into that. Think of the logic stuff for those of you who are going into maybe politics or law. But it's a really neat way to study logic, is separating things into symbols instead. Now, there are things called statements and things called propositions. So if you read through this first example up here, if you read the Times, then you're well informed. Well, that's not a statement. That's a proposition because something's going to happen. Step 2, you read the Times. That's a statement. And statement 3, that is a statement. You are well informed. That actually happens to be the conclusion of this argument. But a statement, again, is something that is either true or false. Plato is a Chinese philosopher. That's a statement. It's false, but 5 + 5 is 10. It's true. Now, not statements would be, are you listening? This statement is false. Well, which statement? You know, that would be kind of a indecisive thing. So when we're looking at statements here, or propositions, we really want them to be either true or false. They can't be a question. They can't be things that can be argued. So we can combine them using lots of symbols. So let's look at this first example here. Not. Okay? So let's use the first one. So if we're going to change John is 2 meters tall, the English sentence would be John is not 2 meters tall. And the symbol is this. So the symbolic sentence, it would be not P. Now I know I put for a Venn diagram here. So if we had our Venn diagram, this is going to be the P, this is going to be Q. Not P. On the Venn diagram, remember that's going to be everything outside of P. Okay? Now let's see if John does not play basketball. Again, our symbol for not, so this would be not Q. So on our Venn diagram, I'm going to put this as P, this is Q. Not Q is everything outside of circle Q. And, so the conjunction and. John is 2 meters tall and plays basketball. Now, an and in the Venn diagram would have been kind of like the union of those things. So in not the union, I'm just having a brain damage moment there. And that would mean, might be easier to look at this. I'm having a brain damage moment. P and Q. So he's tall and he plays basketball. That is our intersection. In symbolic, we actually use a more pointed symbol, but it really means the same thing as that intersection symbol like that. So this would be P and Q. Or John is 2 meters tall, or plays basketball. Okay, so we want him playing ball, and we also want him playing basketball. So that would be a union. P or Q. All right. Write the following using symbolic logic. So the propositions. Tom is taking math and Mary is taking a physics course. What if we called Thomas taking math, I guess T for Tom, M is taking a physics course. This will be M. So this will be T and M. Anne is passing math, but she is failing English. So since it's both and, I'm going to call this M for math and E for English. So if she's passing math, but she's failing English, so that'd be and, not English. Okay? Inflation, wages. So how about stopping inflation or increase wages? So you see how you got to be careful how you denote these, because what if I'd said I was stopping inflation? Then I would not have the not. Let's look at some that are already listed for us. P, good math students go to good universities. Q, good math students are good music students are good math students. And R, students who go to good universities get good jobs. From these statements, write 2 valid conclusions. Well, one conclusion might be that good music students, since they're good math students, would go to good universities. Could you also say that good math students get good jobs? Could you even say that good music students get good jobs? Connecting them all together. So you have a lot of options for a valid conclusion. But now let's look at these symbols. Now this one has a squiggle, but it means the same thing as that other symbol. This would be a not Q. So not Q would be that good music students are not good math students. Now, the up arrow thing, that's and, so P and R. Good math students, oops, go to good universities. And get good jobs. What if we went the other way? What if we were given the statements and then we tried to write it in symbolic? Okay, so for this section, P, Sherlock Holmes is alive. Q, Sherlock Holmes lives in London. Sherlock Holmes is alive and he lives in London. That'd be P and Q. Either Sherlock Holmes lives in London or he is alive. Q or P. See how the order matters? Sherlock Holmes is neither alive nor does he live in London. So he's not alive and not in London. What about this one? It is not the case that Sherlock Holmes is alive and he lives in London. Do you notice how it's not the case that all of this is true? So that's why it's in parentheses. Now, a couple more things. sometimes it can get a little complicated to figure out what the outcome's going to be. So we use what is called truth tables to kind of follow what's going on. So let's look at the and truth table, the conjunction and, P and Q. Suppose you're offered a position in a firm that requires an applicant must be at least 18 years of age and must be a college graduate. So to get the job, you must meet both requirements. So let's look at a truth table. What are our options? Well, we can have both true. Do we get the job? Yes. What if we were 18, but we didn't graduate from college? Are we going to get the job? No. What about if we aren't 18, we did graduate from college, we're still not getting the job? What if neither one of them were true here? It's definitely not true there then. So a conjunction is true when both are true. Otherwise, it is false. Okay? What about or? Now, this or is an either or both. So you have to be at least 18 years of age or must be a college graduate. So you need at least one. What if you're 18 and a college graduate? You going to get hired there? Yeah. What about 18 and not a college graduate? Yeah, they said at least one of them. What if you're not 18 but you did graduate from college? According to this guy, this company, you're okay. But what about false, false? It's going to be false. So a disjunction is true when either are true. Or both. Okay. Now, let's look at a truth table for a negation. This one's really easy. The original's true, then not P would be false. The original's false, not P is going to be true. So there's a little try it that I want you to go through on here.